Mario once again with MIA Microflight, and I just completed another part for this pinball machine that I've been working on. So I'm going to show you what I've been doing here. This is the pinball machine that I show in another video. The, um, the the actual machine. This is the CAD model. You can see it looks quite messy here with all these parts spread all over this working area here on this CAD program. But that's just the way I work. I like working with one idea and then start from that idea and just keep growing and spreading out from that concept. And so that's what you're seeing here. I mentioned some other videos that I like to work as a painter does with a color palette. Typically painters have a palette where they spread all the colors and then they start mixing and matching and whatever they need to do with those colors, to accomplish their final their final masterpiece. I'm not saying that this is a masterpiece. I'm just saying that I work, like a painter. By no means this is this is a perfect machine. This is one of the first machines that I've put together. So it's a prototype. It's still in the prototyping stages, but you can see, the concept and the evolution of this machine here. How I've been doing this. Actually, I started with this particular layout here that you're seeing here. Just this very simple layout. And you can see I have some sort of a spinner here, and I started with an idea of the bumpers, where I wanted the bumpers, and then I went to this setup here, and then from here I started working a little bit more into what you're seeing here on this particular layout here. And this is it's got a lot of stuff here, but as you can see, let me just remove some of these components here so that it's not too crowded here. I'm going to leave those actually. Yeah. Okay, that's a little bit better. You can see some of the components, such as the bumpers, and I have a couple bells here. These are actually bells. Let me get my arrow here. These are bells, and these are the bumpers. These are some just static bumpers laid out, in order to allow the electromechanical bumpers to swing the ball, or to flip the ball, from point to point across all these areas here. And so, but once if you're building something like this, for anybody that has done this, you probably already know this, but this is more for new people that have not seen this before, or not pinball machines, but have not seen what I'm doing here, and are not aware, of the those little intricacies and nuances that happens when you're that you have to take into account actually when you're building a pinball machine. So let me just hide that as well. You can see I've also removed some of these bumpers right here, but basically that's my table. All these are 3D printed parts that you see here, and you can see the underneath of the table. You can see my flippers. They're mechanical flippers. I actually had electromechanical flippers here with solenoids, but I didn't quite. I much like the feel of just a mechanical bumper, something that I can control even though you can also control the ball retention via the flipper with an electromechanical bumper. But I just like the feel of the bumpers, the mechanical bumpers, in my hands better than just the buttons. And so that's why I kept those just the regular mechanical bumpers here that you see here. And you can see how the bumpers, since I'm on the subject of bumpers, how I created these arms here. These arms are very this is a this is a little more elaborate than just having what would this call a guide, directly to the to this arm here and to the bumper here. You can see that there's this extra arm here, and this extra arm allows for a little more fluidity and control on the bumper. It allows for much better angle resolution, as this is switching back and forth, on and off via the mechanical bumper. And so that's why I have these the way you see them here with this additional link here. So if you were to connect this part right here, this part directly to this arm right here, this almost 90-degree arm, and into the into the flipper rather. I imagine this is actually a solenoid that's it's not supposed to be there, because like I was saying, I'm using just a mechanical bumper. But this is the way I had it with the solenoid before. I was activating it like this, and so this extra link allows for that, just a little better ease of control of the bumper, and it's a little more. Allows for more precision, if you will. But this is the way I had it with the electromechanical solenoids right here. You can see there's one option right there, and there's the other option right there, the solenoids. But actually I had it this way, and then I removed the solenoid. So right now it's just just the regular mechanical bumper, as I was saying. So it's more like that. The other solenoids, as you can see them here, there are three that are attached to the bumpers on top of the machine, which sit like that. Let me just remove this because this is not supposed to be there. Let's hide that. Okay, and so you have these electromechanical bumpers here, and I've shown how this works on my on the actual machine in another video, so you can see that video if you're interested in watching this machine in real time, how these bumpers work. And these work very, very nice. They're set up very much the same way that a real bumper is set up on well, these are real bumpers also, but on the full-scale machines. So these are more in line with those type of bumpers. The only thing different here that I'm doing is on the switch setup, I'm making my own contact here, switching, and so I don't have that extra little lever that typically the full-scale bumpers have. They have this little lever that's doing another switching action on a leaf switch on the side of the this assembly here. So I don't have that. So what I did instead is I explained in one of my other videos that I took strictly about the assembly of this bumper setup here. I said that I make my own switches, and I have a switch directly in center with this part right here that's doing the contact as this plate right here, this bottom plate, triggers it. So this plate is floating here via these supports here. This is part of the let's go to this one right here, so you can see that's part of the if we were to that's part of that assembly. That's part of this base right here. So you can see how this base is assembled with my trigger point. My trigger point is actually actually, let's see if I have another one here, because I did several setups here, and some worked okay, some did not work okay. So the way I have it here is you can see that this one has this wire coming out here. So my trigger point here is I have a where is that? So basically what I have is I have a screw that is I have a screw that is attached to this plate right here. This is the bottom trigger point right here, and that screw rides inside. Here's the screw that's attached to that, and that screw rides inside a rides inside a tubular brass tube, or just brass tube. That's about 3/4 of an inch in length. And so that brass tube, like I was saying, rides inside that part right here. And both of these parts, and actually that part right there, that tube, is part of this assembly here. Yeah. That tube sits inside this tube right here. So that tube sits inside. Actually, no, that's not the part. Darn it. Let me just bring this other piece here because, yeah, this is the part that I want to show this on. And so this tube, as I was saying, this brass tube, there we go, sits inside that part right there. Okay, and I'm going through the steps here just to make the assembly so it's easier to visualize this for anybody that's following this video here. And so that part, it's basically what we're seeing right there. Okay, so we're seeing this whole assembly in this view right here. You can see these are translucent parts, that's why it's sort of a see-through. Basically that part sits right there. You can see how this part just floats over these 4 posts here, and it's got additional perforations here to allow some wires for the LEDs that are attached to the top of this hat, meaning this part right here, or what you see here, you know, that top portion right there, which would be that portion right there. That has a pocket also for an LED, so that LED sits in there, comes down through this part right here, goes through this hat. I'm calling this a hat, which is the kicker actually for the ball, and then all the wires go right through, as you can well, all the wires come down through the sides here, through this hole right here, through that hole right there. This is actually a rod, a carbon rod that I'm using to attach the complete assembly to 2 carbon rods that I'm using to attach this complete assembly to this part right here, which attaches to the shaft. Of course, this has a little screw and a nylock nut to retain that part, and these parts are retained here with a pressed fit PVC tubing, little sections of PVC tubing. I have 2 on top that are glued to these carbon rods that are part of the hat. So if you look at the hat, here's the hat. There's that carbon rod that's kind of press fit in there on the hat. There's another one that's supposed to be there. So let's just add that carbon rod there. Okay, so those carbon rods are press fit into this part, so that's not going anywhere. And then that whole assembly rides through this trigger plate and through the table to this part right here, which is holding this, which is holding the trigger point, which is this plate right here, as I just showed, which is holding that. Okay, which holds that trigger point right there. Okay, so and And that screw that I put here on this plate that's attached to that plate, when this rocks, it makes contact with, there's a screw right here. Let me just make this better. So I kind of close this screw here, the geometry here. Okay, so that screw that you see here that comes down here is this plate. This is a trigger plate rocks. It makes contact with this brass tubing, and so there are two wires attached. One is attached to to establish the full switch. One wire is attached to the brass tubing here. The other one is attached to this trigger point right here, the screw, via these openings here. So these openings here is where the wires come in. The one comes in this way, like that, and attaches to the very top portion of that screw right underneath that trigger point or the trigger plate, and then the other wire is on the other side that attaches to the brass tubing, and those two wires come down through these openings here. See these slots right here, and these slots right here, and then they connect to the rest of the wiring underneath the table. I don't show the wiring here for simplicity, but basically it is just as I explained. If you follow, if you understand a little bit about electromechanical switching and bumpers and solenoids and stuff like that, you'll be able to follow what I'm saying here. Otherwise, it's a little difficult if you're not familiar with these things. But basically, that's my solenoid here, and that's how I'm doing the switching. Very simple. There is a gentleman that I stumbled upon one of his videos where he shows a similar setup here to mine, but his switching is done with a tactile switch, one of those just those press button switches that I use for computers, for miniature stuff, or for a lot of people that use the Arduino microcomputers, to do projects. They use those little switches just to switch on and off, do clock pulses and stuff like that. So he's using one of those switches on top here, and connected to this plate as well, kind of similar to what I have here, except I'm using a tube and a screw here. But he's got one of those switches on top. I contemplated using that similar setup, but I did not have it just did not have the sensitivity, the trigger sensitivity that I was looking for when I did my setup here. And so this is a lot more sensitive the way that I just described, and that's the reason why I came up with this screw and tube, brass tube concept of my own switch. So, but pretty much the rest of the geometries and assembly is very similar to the full scale bumpers, electromechanical bumpers that I use on the full-scale pinball machines. If you study that, which I've done, to a good degree, on and off, I've been looking at these things and just getting ideas from the full-scale machines. I like to look at the full-scale products or items or machines and devices, to get a full understanding of how these things work. And there's a lot of information on these things online. You can see a lot of sketches and diagrams of these types of electromechanical devices that are used on these machines, that you can get a pretty good, decent idea of how these things work. So that's basically what I've done here, to do a lot of this work that you see here. So a lot of this may be very similar, but it's my own geometries. I do this from the bottom up. I start from nothing, and I start sketching these things based on just what my mind is these things look like, inspired by the real thing, and so that's why it looks very, very similar to the full scale ones. Some of these other things are kind of my own concoctions of ideas and things that I've done, just based on my needs. So they say invention is necessity is the mother of invention. You've probably heard that term, and that's how I approach these things, because as I need something, I start creating those things. I need to do this. This needs to be like this, like that. I need this height, for a particular reason, and so that's how these things get. I need a certain width, to clear, the ball going through. So a lot of that is just common sense when you start thinking that way in a logical form. If this, then that. That's logic. So a lot of these pieces are done that way. Let's see. I talked about the flippers. I talked about the electromechanical switching here that I'm doing here. So this right here on the right side is my trigger point. You can see my this little box here. That's for my actual trigger. Let's see. Do I have that trigger somewhere? Um, I did do that little trigger. I wonder what I did with that drawing. It's probably hidden. But let me talk about the lenses here. There's a lot of lenses here that I have been creating for the machine, and you typically need to do that if you want to add a little more immersive feel on the machine. You know, just a blank piece of wood is no fun just rolling a ball through that. But if you have lights and you have electronics to go along with those lights, you know, lighting sequence. It says scorekeeping. Total registration, all that stuff. You know, in addition to all these electromechanical bumpers and switches, you know, to trigger things on and off and score your points. You know, it makes it a lot more fun. And so I've been doing all these lenses, you know, for all these LEDs here. And this is basically inspired. What you see here with these stars and these arrows is basically inspired by that little machine, which after I started doing these two setups here, I came to do this one here, and I had a different layout here that you see here. But then I bought one of those little machines, which is this one right here, and the layout of that machine is made by Rocker is it's a 3D. They call it a 3D puzzle pinball machine. So it's a great little machine. It's a little expensive, but it's a great machine because it's got sounds. It's got the works in a very miniature package. I believe this machine is. Let's see if I still have the dimensions here. Yeah, it's about. No, that's actually too small. That machine is. I believe that machine is 19 by I forget. It's somewhere around. It's a little bit bigger here. That machine's a little bit bigger than this. It's about 9 by 18, I believe it is, that machine. So it's not a big machine, but it's got, like I said, all the bells and whistles. And so what I did here, I started sizing this, scaling it up, and to see how that would those components would align with my setup that I had here, and it kind of it's similar. So I started basically working on with a similar geometry as that machine here. In particular, the lights, because I am going to mimic the light sequence here just to keep the score very simple. Instead of having just another counter here sitting on top of the machine, I don't plan on having another box here, you know, with for the scorekeeping and the totals and all that, the high score, etc. So I really like the way this machine was done with scorekeeping. Is very simple. Every one of these stars here, and this is spread symmetrically here, this star gives you 100 points when it's lit up, when you hit the right electromechanical, or sensors rather, or electromechanical switches. So this gives you 100, this was 200, 300, 400, 500, 600, 700, 800, 900, and 1,000 points for this star right here. And then these arrows light up, you know, as the machine initializes and then resets, and as you keep score, as your score keeps going high, you know, it's certain lights trigger, and you know, it's really immersive little machine. It's a great little machine, like I said. Look into that machine. I'm not trying to advertise for that machine, but since I'm mentioning that, it's worth looking at that, and so you can follow up also with what I'm saying here in this video. Great little machine. The way they're doing these triggers here on that particular machine, as I mentioned in my other video, is a very simple setup here, and I had contemplated doing a very similar setup back in the mid 2024. when I was itching to build one of these machines. So I said, what's the easiest way to build bumpers? So I had contemplated building some really simple bumpers, just direct, what I call direct drive bumpers, meaning direct from the solenoid directly to the bumper itself. And in this particular design assembly, you can see that that's exactly what I did here with this particular one. So I revisited that. I did one and it didn't work out too well. And just to give you an idea, this is the original table that I use. It's just a little piece of wood that I had here. You can see my flippers. I did them with also ball bearings. These are escape ball bearings. And so this is where I had that bumper that I was discussing. That here, let me turn this around because this is upside down. Basically, there are my early mechanical bumpers that I was experimenting with. You can see I'm just using this work, but it's because of this is directly coupled to this without a secondary link. It tends to get stuck there, and also it also has to do with the position of this return spring that I'm using as a rubber band. This has to be in line with this spring that's in line with this, so that it has a better option of returning it without binding. But anyway, that was one of my early flippers. But basically, this is where I had that original direct drive solenoid that I described, that I'm describing here before I stumble on that rocker machine, that little machine, and so. But basically, it as I was saying, I refined that design, and I came up with this particular one right here that I also show in my other video, my recent video, where I'm discussing also this with the real machine in view. The way these bumpers are done is basically, you go direct from the solenoid here. From the solenoid on the little machine, they had the stem here, or the shaft. I believe that they had it customized, where the shaft itself, it has a screw. Basically, it's a screw at the top, and that screw, and to that screw to the top, they attach this metallic hat with a nut to retain it, and on top of that, they just press fit the cap of that hat, or the top portion of that hat, which is just on that machine, it's all laser cut plywood pieces. There's no gluing whatsoever. Everything's interlocking. It's a very, very very neat little machine, and so that's how they do these electromechanical bumpers. And the way they have it laid out on their machine is they have basically the three laid out as you see it here, because this is a direct a replica of the taking dimensions from that machine as far as the layout is concerned. And what they did is they created they manufactured a mesh here for the top to make contact with the hats, with the metallic hats. They did a sort of a delta shape mesh, like I showed here. And of course, these things are, let me edit that. Okay, so as I was saying, they created this metallic mesh, stick-on mesh. It's got a sticky back, and you're supposed to lay that on top of the wood table, or the base of the machine. Come on. And that creates, via a connection to a wire underneath the machine, that basically creates the so it's something like this that creates the okay. Oh, I erase that. I don't want to erase that. sort of like something like that. Here, let me add another piece here just to make it more complete here. So they have this is attached also to another section here, and that's a hole through the mesh that goes through the table, and this is where a screw is attached to a wire that completes the switch from this mesh to the solenoid electronics. So that's sort of like that. There we go. So basically, you have a wire connected here, you know, through a little screw here, and of course the solenoids are right on top of here, inside these holes here, and then that connects, like I said, to a wire, and the other one connects to the metallic heads of the solenoids. And when the ball makes contact between this metallic plate and the head of the solenoid, it triggers the particular solenoid that is nearby, and so it bounces back and forth. So it's a nice setup here. It's got great bouncing effect here. The way they laid this out with the just those static bumpers that are spread out around here, just to get that ball moving. You know, it creates some excitement there in that corner as you hit the ball. So it's a great little setup. And so basically, when I bought this machine after the fact here, I go, well, let me revisit my original setup that I did here. So I started refining this very simple direct drive solenoid, as you see it here in this view here. But these work better here because they have better support. This right here has no support whatsoever on the stem, and so every time the ball hits it hard here, this whole assembly with that brass tubing, because it's attached directly to the shaft of the solenoid, and the only thing supported here is just the solenoid frame. This tends to move, and there's a possible risk that you're going to damage, you know, the shaft of the solenoid. So what I've been contemplating doing with this particular setup here is doing something like this. I also sketch in the mornings, you know, any ideas, and then I transfer them to the computer. I started doing this setup right here that I need to retain. I need to make this a 3D printed part of the base, sort of just extend this neck here so that it has support at the top of the at this section right here of the that brass tubing that's directly coupled to the solenoid. So it's got a little more support there. You know, very little plate, because it's obviously got to go up and down with these, but it's got side support all the way around with this particular neck that would be part of this. I still have to build that. That would be part of this. That would be part of this base right here. So this part, the way I designed it, also is a two-part. If you can keep up with what I'm saying here, because this is not meant for everybody. You know, some people get overwhelmed with a lot of talk, a lot of explanation, and some just can deal with that. You almost have to be a little bit of a geek, you know, to